Hello, welcome to Becker Breaks It Down. In this episode, we continue to explore sinusoidal functions and their graphs. Perhaps you were wondering, why do we call sine and cosine sinusoidal? Are you ready? Because any sine function can be written as a cosine function and vice versa. Because cosine is just merely sine shifted to the left pi over 2 units. See? So your starting point when you're writing a sinusoidal function given its graph is dependent on, well, you can choose your starting point, but then if your starting point is at the midline, you'll write a sine function. And if your starting point is at the maximum or minimum value, then you're going to have a cosine function. Okay. All right, so we're going to construct a sinusoidal model. All right, so first figure out what's the function. It says if the selected starting point. So you get to choose your starting point. Now my advice is first look at the y-intercept, okay? Because if the y-intercept is at the midline, the maximum, or the minimum, I would use that as my starting point. And if it's not the y-intercept, if your starting point is not on the y-axis, right, then there's going to be a horizontal shift, and you're going to want to think about what that is, okay? So next comes the other pieces of our function. So amplitude, midline, and period. So take a look at the maximum value and the minimum value of your function. The amplitude can be found by going max minus min divided by 2. And the midline can be found by going max plus min divided by 2. Okay. Now, when it comes to that amplitude, I do want you to pay attention to whether or not it should be negative, because if the function has been flipped, you want to change the sign of the amplitude when you write your function. And then finally, the period. You should be able to see the length of one cycle of sine or cosine looking at your graph. To get the b value, that's what goes in the function, you need to go 2 pi divided by the period. Okay, and we're going to write our sinusoidal functions like y equals a, and then we'll have like our trig function. And then in parentheses, we'll have our b value. And if there is a horizontal shift, we'll put that in there. So you'll have like double parenthesis usage going on if there is a horizontal shift. And then you'll have your k. Okay. So this is how we're going to write our functions. I'm not going to have you distribute the b value. We're just going to write it like this. Got it? Okay. So here I have an example. All right. And so, like I mentioned before, look at the y-intercept first. If it's max, min, or midline, it's a good starting point and there's no shift. So this is what one cycle of cosine looks like. So I said cosine because my starting point is at the maximum, which is why it's cosine. And therefore, since it's on the y-axis, there's no horizontal shift. I determined my amplitude to be 2. And that's because I could visually see it. Now, if you can't visually see it, you can do the amplitude math, because your max, oops, let me get a pen out here, because your max is 5, your min is 1. So that means that amplitude would be max minus min divided by 2. So 4 divided by 2 is 2. And then your midline, k, is max plus min divided by 2. So 6 divided by 2 is 3. So you can do like the math where you use the formulas. If simply looking at the graph itself is confusing, you can use those formulas. The period, so I see in my graph that one cycle is 4 units long. So therefore my B value is 2 pi divided by 4, which is pi over 2. So this is what my function looks like. So there was no horizontal shift. Okay, so let's take a look at some examples. So select a starting point. Now this time I don't like that y-axis starting point because it's not the max, it's not the min, and it's not the midline. Okay, so I'm going to want to choose something else. All right, I'm going to get out my highlighter and I'm going to highlight one cycle. So I really don't like any of my max or mins. I'm kind of liking the -6, right? So this is what I'm choosing to work with, all right? So based on my starting point being at -6 there, this is what I know, because that's the midline, all right? So this is going to be a sine function. Has it been flipped? Yes, it has been flipped, okay? And I'm starting to the left 6 units, okay? Identify the max and the min, determine the values of A and K. So like my function has a max of 4 and a min of 4, -4. So this is pretty easy. Like I feel I don't need to actually use those formulas because clearly my amplitude is 4 and my midline is 0. Identify the period and then determine the value of B. So like the one cycle starts at -6 and it goes to 4. So from -6 to 4, that's 10. So my period is 10 units. B, I need to do that math. I need to go 2 pi divided by the period. So 2 pi divided by 10 is going to be pi over 5. So that's my B value. So now I'm ready to write my function, okay? So I'm going to have y equals, and it was flipped, so negative, and then my A value is 4. And then this was a sine function based on my starting point. So sine. And then in parentheses, first I'm going to have my B term. So my B term is pi over 5. And then I had a horizontal shift. So x plus 6 is that shift to the left 6 units. And then k is 0, so writing plus 0 is optional. But that would be my function, right, for my starting point. Now, if you had chosen a different starting point, there might be a few things that are different here, but we should all have the same amplitude, period, and midline, okay? Because basically you get to choose the starting point. It's like whatever seems most obvious to you when you're looking at the graph of your function, okay? So if I take a look at this one, select a starting point. Well, I do not like the y-axis at all. So I need to choose a different starting point. I'm also going to highlight one cycle. So like, what about this? Doesn't that look like a good starting point? Yeah, all right. So here's one cycle, right? So based on my selected starting point, that is occurring at the max, so that'd be cosine. Has it been flipped? No, it has not. And determine any horizontal shifts. Well, I'm starting 1 unit to the right, so we have right 1. Determine the values of A and K. So I can identify the max of my function. My max is 1, and the min is -5. Okay, so maybe this time I actually want to use those formulas for max and min and amplitude and midline. So amplitude would be max minus min. So that's going to be 1 minus -5, which is 6 divided by 2, so that's 3. So the amplitude is 3. And then the midline, I want to go max plus min. So that's going to be 1 plus -5, which is -4 divided by 2 is -2. Identify the period. So I highlighted one cycle, and it started at 1, and it ended at 7. So from 1 to 7, that would be 6. And then my B value is going to be 2 pi divided by 6, which will be pi over 3 once I simplify it. So once I've got all my key pieces, I can then write my function, okay? So we got y equals, was not flipped, so I'm starting with my a value of 3, was cosine. And then in parentheses, I have b, which was pi over 3. And then I had a horizontal shift, so right 1 is going to be x minus 1. And then k is minus 2. So based on my selected starting point, I wrote a positive cosine function with a horizontal shift to the right 1 unit. Okay, but it's all dependent on your selected starting point. So if it's at the midline, it's sine. The max or min is cosine. Has it been flipped? If so, make sure that your a value is negative. If your starting point is not on the y-axis, there's a horizontal shift. You can calculate your amplitude and midline by using the maximum and minimum values. And then the period. There's what you see in the graph and there's what you see in the function. So what you see in the graph, take that, go 2 pi divided by the period to get your b value. And that's how Becker breaks it down.